Hello. In this question, we will see a traveling salesman problem, a classical problem of traveling salesman problem. Now let's read it. The weighted graph H representing the traveling cost between 5 customers has the following weighted adjacency table. Question A, draw a possible graph for H. Now, you see in this table, the customers are the vertices A, B, C, D. You see that I can go from each vertex to another one directly. So this is a complete weighted graph. So I can find the Hamiltonian cycle for sure. The problem has a solution. Now, if you will read further down the question, it says, starting from customer E, use the nearest neighbor algorithm to determine an upper bound to the traveling salesman problem. And C says, by removing customer A, use the method of vertex deletion to determine a lower bound to the traveling salesman's problem. Now, once you will see nearest neighbor algorithm and deletion vertex algorithm, immediately you should understand that we are talking about the traveling salesman's problem, even if they don't tell me clearly. Now, let's do the first part, A. The most easy way to draw the graph is put the points, the vertices, in a circle form, A, B, C, D, E. Of course, you can do it with different ways. This is the easiest, I think. So I connect, you see I can go from each vertex to all of them. So from A, I will connect all the vertices. I think this is the easiest part of the question. From B, I can go to all of them also. From C, the same. And D, also the same. So I made my graph. Now, let's see B. What does it say, B? Now it says, starting from customer E, use the nearest neighbor algorithm to determine an upper bound to the traveling salesman problem. So how this works, the nearest neighbor algorithm, it's easy generally. This is my starting vertex, E1. Now I go to my vertex and check which is the lowest value here in this row, 7. So from E, I will visit 7, which is C vertex. So the second after E is C. Now, since I visited this vertex, I delete it. I should not revisit it. Now, from C, which is the lowest value? D, which is 3. So from C, I'll go to D, my third vertex, and I delete this vertex so as not to visit again. Now from D, the lowest is 4, which means from D I go to A. I delete this vertex. Now from A, I should visit B. So this is my 5th one. And from B, I have to go back to E, where I started, which is 9. So what's the answer to the problem? I'll write the order of the vertices that I visited. It's E, C, then D, then A, then B, and then E again. So you see, this is a Hamiltonian cycle, and the value, the whole, the upper bound will be 2 plus 9 plus 3 plus 4 plus 7, which is 25. Now let's go see the C question, sub-question. By removing customer A, use the method of vertex deletion to determine a lower bound to the traveling salesman problem for H. Now, let me clear this. how it will work, this one. Now I calculated the upper bound here. Now I need to find a lower bound. How I do that? To find the lower bound, I need to find, after deleting this vertex A, I need to find for this table here the minimum spanning tree. There are many ways. You can use Prim's algorithm, Kruskal's. I consider Kruskal's is the easiest. So what do? I remake the graph, the subgraph basically, E, B, C, D, without A basically. I connect all the vertices because it's a complete weighted also graph, the previous one. So now I just need to find the minimum spanning tree for this graph. So what do? I will check. I will write down the values of all the vertices. From E to B is 9. From E to C is 7. From E to D is 13. Now from D to B is 12. From D to C is 3. And from B to C is 6. Now, how I will calculate the minimum spanning tree? Easy. I start with the smallest. Now, if you remember, the minimum spanning tree is what? Connect all the vertices with the smallest, following the smallest edge, using the smallest edge as for all the edges. So I have to visit all the vertices by using the smallest value of the edges I have. So which is the smallest values here? DC, which is 3. Next is BC, DC. Next is CB, which is 6. And the next one is C to E, which is 7. Now you see I visited all the vertices. I didn't make any cycles, and that's the minimum spanning tree. So how much is the minimum spanning tree? 7 plus 6 plus 3, which is 16. And that's the lower bound, which means I cannot find a cycle which is less than this value. And that's the solution to my traveling salesman problem.